Hello students, in this video we are going to solve one numerical example based on the work energy principle involving the springs. So here we are going to calculate the work done by spring force also, right? So read the statement. The 2 kg smooth collar means there is no friction, is attached to a spring that has an unstretched length of 3 meters. Unstretched, original or undeformed length is 3 meters. Determine its speed at A when it is drawn to point B and released from rest. See, when the collar is at point A, the spring is undeformed. It is said that the unstretched length of the spring is 3 meters. So when the collar is at B, length of the spring is 3 meters, which is undeformed or unstretched. Now when it is drawn to point B, the spring is stretched. Now from B, it is released from rest. That means, what is the velocity of the collar at B? It is 0, released from rest. So when it reaches again this point A, you have to find out the velocity of the collar. So you know velocity at B, you have to find out velocity at A. So use work energy principle from B to A, initial to final positions. So using work energy principle from point B to point A. So here B is the initial position, A is the final position. So what is the work energy principle? Change in kinetic energy is equal to work done. Final kinetic energy minus initial kinetic energy is equal to work done. So it is kinetic energy at A minus kinetic energy at B is equal to the work done by all the forces from points B to A. Right? Now, what are the forces doing work on the collar when it is moving from B to A? See, 2 kg smooth collar, so mass is there, so the gravitational force is acting. And before finding the work done by the forces, first we have to understand what are the forces acting on the collar. So one is the gravitational force, second is the spring force, collar is attached to the spring, and being it is smooth collar, there is no friction, right? So now two forces are acting, gravitational force and the spring force, and of course there is a normal reaction from this rod on the collar. So in fact 3 forces are acting, gravitational force, normal reaction and spring force. Out of these 3 forces, 2 forces are not doing any work because it is moving from B to A, so it is having only horizontal displacement. So the work done by gravitational force is 0. Gravitational force is not doing any work. And the work done by the normal reaction on the collar, it is always 0 because there is no displacement in normal direction. So only spring force is doing work. So this is equal to work done by spring force, right? Now, what is the kinetic energy at point A? So it is half mv a square. So it is half into m is 2, v is say v, velocity at A, square, that is equal to v square joules. Right. Now, kinetic energy at point B. Kinetic energy at B. So it is half m into vb square, which is equal to 0 because it is the velocity at B is 0. It is released from rest. Now work done by spring force. What is the formula? Work done by spring force is given as K by 2 into x1 square minus x2 square. x1 is the deformation of the spring in the first position, that is when the spring is at B. x2 is the deformation of the spring in the second position when the collar is at A, and K is the stiffness of the spring, which is given as 3 Newton per meter. So now see what is L0, undeformed or unstretched length of the spring. It is given 3 meters. 3 meters. And what is L1? L1 means length of the spring in the first position. That is length of the spring when the collar is at B. So this length, it is given 3 meters, 4 meters. So the length of this hypotenuse is square root of 3 square plus 4 square. That is 5 meters. And what is L2? Length of the spring in the second position. When the collar is at A, its length is 3 meters. Right. Now x1. What is the meaning of x1? Deformation of the spring in the first position. That is L1 minus L0. So L1 is 5 meters, L0 is 3 meters. That is equal to 2 meters. x2. Deformation in the second position. L2 minus L0. L2 is 3 meters, L0 is 3 meters. That is 0. Because when the collar is reaching A, the spring becomes unstretched. Length of the spring will be 3 meters. Right? So the deformation is 0. So now putting all the values in this expression, kinetic energy at A, it is B square, minus kinetic energy at B is 0, is equal to work done by spring force K by 2, K is 3 by 2 into x1 square, that is 2 square minus x2 square, 0 square. So solving this equation, you get velocity of the collar at point A as 2.45 meters per second. That is our answer. So its speed of the collar when it reaches point A is 2.45 meters. Understood? Thank you.